Okay, I don't know that. All right, guys. Are there any questions over the homework? Any question over any of the homework assignments?
Thank you.
You're welcome.
Yeah, there's nothing.
So there's no questions over the homework assignment. This is the first thing we're going to look at. And again, I need to start getting to more of these slides so they're not as pixelated. The square root of a negative number property. If r is a positive number, then the square root of negative r is I square root of r. Now that's not saying r is not, that we can't take the square root of it. We can just move I out and then we can deal with taking the square root of whatever r is. Which is most of what we did the other day, especially when we were simplifying radicals. Because if we had to say the square root of negative 9, we moved the negative out as I, then we took the square root of 9. By this first property, it also follows that I times the square root of r squared is going to be negative r. Because when we square a square root, they cancel out. And I, again, is the square root of negative 1. Square root of negative 1 squared would go back to negative 1, which just tells us that it's going to be negative r. Any questions on this so far? You're good. It's just saying if we take the square root of a negative number, we're going to get I, and then whatever the square root of that number is. And if we square it, we're just going to get back to that negative number. Now, what we're going to look at with these here are finally solving these equations that we really couldn't solve before. So if we look at this first one here, x squared plus 4 equals 0. Now, because it doesn't have a middle term, we don't have x to the first power, we can use the square root method. And the square root method states that we want to get whatever is being squared, the variable being squared by itself, or the set of parentheses as being squared by itself. So here the first thing we can do is subtract 4 from both sides, which will tell us x squared is equal to negative 4, which up to this point we couldn't find. What times itself would be negative 4. But at this, we can take the square root of both sides, and the square root of x squared is equal to plus or minus, because whenever we square root both sides, we do need the plus or minus. You're good. But up to before the last 2 days, before this week, taking the square root of negative 4 we couldn't do, because we didn't know what times itself would give us negative 4. But now we know that that negative is going to come out as I. It's our square root of negative 1. It'd be 2I, because the square root of 4 is 2. So we get this here. Now, realistically, it's telling us that we have two solutions, that x is equal to 2I, and x is equal to negative 2I. We have this here. And part of yesterday's lesson, the complex conjugate theorem stated that if a plus bi is a solution, then a minus bi is a solution as well. 2i is a solution, so negative 2i is a solution. If we have one, we need the other. So does this kind of make sense without a plus bi, a minus bi? If we have a solution with I, we're going to have two of them. We're going to have a positive and negative version of that. Questions on this here so far? Okay. Let's look at this next one here. So 2x squared minus 11 equals negative 47. Now we can still use the square root method because we don't have a middle term. So we can add 11 first. If we add 11 to both sides, we'll get that 2x squared is equal to negative 36. What do we need to do next? Divide by 2. Because we need x squared by itself first. We want it completely by itself first. So we're going to divide by 2, which will tell us that we have x squared is equal to negative 18. Then we would square root it. Now the square root of x squared is going to be x is equal to plus or minus. Well, the negative 18, we will have I. I can hand it back to you if you want. Did you just turn it in, or is it? Okay. So we will have the I. Now the square root of 18, is 18 a perfect square? 3 square root of 2. So we have plus or minus 3i square root of 2. And again, the yellow calculators, the 30xs, are very nice with simplifying radicals, especially if we want to keep it in radical form.
What would happen if the I was supposed to do?
So we had square root of 2i.
And then the 3 was just like that. Would that still be the same answer?
This would not be. This would be with the I outside.
Would be the same answer?
Yes. This is essentially saying that we have 3 square root of 2 times the square root of negative 1 having the I inside. Now, I write the I in front of it, and most do, just because if we have to rewrite this multiple times or it's not the final answer, there's a tendency that I might sneak into the square root. Because a lot of times we have numbers or stuff behind the square root. If we're not paying close attention, we suddenly think it's inside. So that's most of the reason why we leave it out front, so that it stays out front. It's also the same reason, like when we add or subtract a number and we have that plus or minus, we put it in front, because we know that plus and minus is not affecting that number we just added or subtracted over. Does that kind of make sense? Any questions on any of this here? And this is meaningless, but most of the reasonings behind, or kind of the logic behind how we write stuff, falls under number theory, which is a whole branch of mathematics that they go into doing that kind of stuff. So let's look at this next one here, and this will finish out the first page of the note sheet. Now, when we look at this problem here, so we haven't finished, we're at the bottom of the first page. Find the zeros of f of x equals 4x squared plus 20. So if we're finding the zeros, we're just trying to find out what value of x is going to make this function equal 0, yes? So really what we're looking at is 4x squared plus 20 is equal to 0, yes? Now we could try graphing this, but it's not going to tell us anything. And one way we can see this is either A, graphing it, or B, thinking about a quadratic, because that's our U-shaped graph, yes? Well, normally, the smallest point's on the origin, 0, 0, yes? So the 4, the positive 4 tells us it's increasing faster. That just means it's skinnier. The plus 20 tells me it's moving it up 20, yes? Well, if it's already going up and we moved it away from the x-axis, it's not going to cross it. So that means if we tried to graph it, it wouldn't cross the x-axis. So we need to do something else. And again, those transformations, that's why they were helpful. It's to give us an idea or a picture of what the graph is going to do. What is it going to look like? Or for us here, is it going to hit the x-axis at all? Here, no, so okay. Now, luckily for us, there is no middle term, so we can use the square root method, like we've been doing on the last few, and subtract 20 first, which will tell us that 4x squared is equal to negative 20. Then we're going to divide both sides by, telling us x squared is equal to negative 5. What do we do next? Square root both sides. It shows us x is equal to plus or minus. So we're going to have I, because the negative is going to come out as I, yes? Square root of 5. 5 is prime, isn't it? That's it. Any questions on any of this here? Yes. One thing I will say, because I realized I didn't mention this earlier, I'm going to write up here. We'll say that we have this here as the answer. That is fine leaving it as this. Leaving this as the answer is fine, because the square root of 5 is an irrational number. It's a non-repeating, non-terminating decimal. So the only way that I could, if we could actually possibly add or subtract these, is if I turn that into a decimal. Also, it's imaginary. I can't actually add or subtract these two here. Yes? Now, I just picked 3. I'm just kind of as a side point. -3 plus or minus 11. Can we actually add or subtract these two numbers? Yeah, we can do -3 plus 11, -3 minus 11, yes? If we get to a point in solving where we get something like this here where we can actually add and subtract them. So we would have x equals -3 plus 11, and x is equal to -3 minus 11. So here x is equal to 8, and here x is equal to -14. We want to go all the way down to the end. Does that make sense? But if we end up something like this here, we don't even need I. Even this, we would leave it. Because the only way to add or subtract is changing it into an irrational number. That's not making it better. So we can leave it as this here. The only reason we would ever want to add or subtract these here is if a part of the question it tells us to approximate your answer to the nearest tenth or nearest hundredth, then we actually need to add and subtract. Y'all kind of make sense? Okay, that was just kind of a side note. We're going to look at this next one here. Now, for the most part, every single method that we've had, especially when we had a middle term, is we wanted to get the equation equal to 0, yes? I want to do this one a little bit different. Now, with the square root method worked great in 2 cases. One is if we only had x squared, we didn't have a middle term. And the other case was if we had a set of parentheses squared, yes? What I want to do with this here, we have this to start with, yes? I'm just going to try to factor the x squared minus 16x plus 64. I want to factor that first. So we're going to do this a little bit differently, and there's a reasoning for it, that we're not messing with the 100. So if we look at x squared minus 16x plus 64, there's no greatest common factor. Since 64 is positive, our signs are the same and they match the sign of the middle term, yes? So positive and negative means that these are both negative, yes? What are the factors of x squared? X and x. Now the factors of 64, we have a few. We have 1 and 64, 2 and 32. 3 doesn't work. 4, 1, 24, 4, and 16. 5 doesn't work because it doesn't end in 0 or 5. 6 doesn't work. 7 doesn't work, but we also have 8 and 8, yes? I'm going to use 8 and 8. Now, if we check this here, x times -8 is -8x. -8 times x is -8x, which gives us -16x. Is that what we wanted? Okay. I know I went a little quick through that, but are there any questions on how we got that factored? Is there something interesting about our factors? Well, both of these are the same, yes? If I have something multiplied by itself, how could I rewrite this? As x minus 8 what? Squared, isn't it? Because x minus 8 times x minus 8 is the same as x minus 8 squared, yes? X minus 8 squared, yes? What are the two ways or two setups that we could use the square root method? One is if we had x squared by itself, yes? Or if we had what? A set of parentheses squared, yes? Do we now have a set of parentheses squared? Which means at this point we can square root both sides and solve. Here the square root and square would cancel, telling us that x minus 8 is equal to plus or minus 10. What can we do next? We can add 8 to both sides. And whenever we add something to both sides and the other side, one side has the plus or minus, we want to put it out front. So we say that x is equal to 8 plus or minus 10. Can we add and subtract those two numbers? Yeah, so we'll need to do that. So this is telling us that x is equal to 8 plus 10, or that x is equal to 8 minus 10. Well, 8 plus 10 is 18. 8 minus 10 is negative 2. So our x is equal to 18 comma negative 2. But that's kind of nice. Yes. Yes. Now this here is kind of nice because we're able to get it to a set of parentheses squared, use the square root method and solve, yes? Now if we're able to get every single quadratic that we come across into a set of parentheses squared, we can just use the square root method to solve it, yes? Now this quadratic that we started off with here, this here has a special name. It is a perfect, all right, let's see here. I always mix this up because we have the sum or difference of perfect cubes, or sorry, the sum of difference of perfect cubes we haven't even covered yet. The difference of perfect squares. This here is a perfect square trinomial. Trinomial polynomial with 3 terms, and it's perfect square because we can rewrite it as a single set of parentheses being squared. And that's what's nice for this here, because if we can write every polynomial as a set of parentheses squared, as this perfect square trinomial, then we can use this method for all of them. You all kind of see how that works? Because if I can rewrite every polynomial of this form, or get it to that form, we could solve it. And that's what completing the square is that we're going to get it into a form that we can do this to it. Does that make sense so far? This here, completing the square, is the first method that we will learn for solving quadratics that will work every single time. It does not matter the setup or the answers, type of answers that we get, it will find the answer. It will find the solutions for all of them. Now the first thing is actually making a perfect square trinomial. Being able to turn any quadratic into a set of parentheses squared. Because if we're able to do that, we can solve any of these here. And it works out for this here, x squared plus 14x plus c. C, and we'll be using this again tomorrow, is b over 2 squared. To give us a perfect square trinomial, the constant term c is going to equal b over 2 squared. And again, this is referencing back to standard form, which is our ax squared plus bx plus c. And in this case here, what's the value of b? 14. We would take the sign with it, so it would be positive. So for us here, so c is equal to b over 2 squared. Well, in this case, b is 14. Now we could type this all into the calculator at this point and let it do it for us, but let's go on and divide by 2. What is 14 divided by 2? 7. 7 squared is. So the value of c that will make this a perfect square trinomial is 49. So our equation is x squared plus 14x plus 49. Questions on any of this so far? Now we need to factor it down to a set of parentheses squared, because that's what we're really trying to get to in solving. By completing the square, we need it as a set of parentheses squared, and it's actually easy to get. We know we're going to need x first. Well, this equation's in terms of x, so we will have x. If it had been y squared plus 14y plus 49, we wouldn't put x, we would put y, because that's just the variable we're working in. And what works out nicely is because we could go through the whole process we did on the last one, 2 sets of parentheses. Find the sign, so positive and positive would be plus. Factors of x squared are x and x. And then we'd look at the factors of 49. And again, because we want them to be the same, those factors of 49 would be, so we'd want 7 and 7, yes? And we said that the sign would be plus, yes? Let me get a highlighter. Does that match up what we have inside the parentheses before we square it? Because we said it would be plus, right? 7's positive. The factors of 49 we need was 7. It works out that what goes in here with x every single time is going to be the number before we square it and its sign. So if it had been negative 7 before we squared it, what went inside the parentheses would have been minus 7. And this is all we're going to do with it so far. We're not going to go through the full process of completing the square yet, but I want us to get used to finding c, finding that value that's going to make it a perfect square trinomial. Questions on this here? Okay. And again, for this next one here, c is equal to b over 2 squared. And for this here, what is the value of b? It's 8, positive 8. So we have 8 over 2 squared. And this, again, when we factor it, this is why I don't just plug it straight into the calculator, because, again, what's inside the parentheses before we square it tells us what's going to factor to. And 8 divided by 2 is 4. And 4 squared is 16. So this here would be x squared, well, yeah, x squared plus 8x plus 16 with it not factored. But if we factored it, I definitely did not give myself enough space, would be exactly, as y'all are saying, be x plus 4 squared. Let's look at the next one. And when y'all are doing your homework or the assignment, you're not going to have to write out c is equal to b over 2 squared. I'm writing it out so that y'all get familiar with it, or knowing what it is. So for this one here, b over 2 squared, what is the value of b? Negative 2 over 2 squared. And negative 2 divided by 2 is? And negative 1 squared is 1. Which tells us that this would be x squared minus 2x minus 1. Or factored, well, we're going to have x. What number is going to go in there with it? Minus 1. Because the number inside the parentheses before we squared it was negative 1. And again, if we went through the factoring method steps, we would look for greatest common factor. We don't have one, so we'd have 2 sets of parentheses. And this should be plus 1, not minus 1. I'm glad I looked back at that, because our final value of c was positive 1, not negative 1, yes? Yep. And again, when we factored it, we would have 2 sets of parentheses with 3 spaces. Since the third term is positive, our signs are the same, and they match the sign of the middle term, which is a negative. So they would have both been negative. Only factors of 1 are 1 and 1. So we end up getting x minus 1 and x minus 1.
So if our final answer is positive on that part, why is it negative 1? Get done.
Because this here, the value of c is always going to be positive. The value of c is always going to be positive. Because what are we doing to it? We are squaring it. We're multiplying it by itself. And anytime we square a number, it will always end up being positive. Because this is also part of the reason why we can't take the square root of a negative number. It just doesn't work. Now, inside here, before we squared it, it was negative 1. So if we went through the factoring process for this here, since the third term is positive, the signs are the same, and they match the sign of the middle term, which will be negative and negative. Factors of x squared are x and x, then we would have 1 and 1, which does factor to x minus 1 squared. And it's kind of a little bit of a cheat or a shortcut to say, okay, what's ever in that parentheses before we square it is what we'll end up with.
That is every time?
Mm-hmm. And it's also working with the way that the middle term for these perfect square trinomials works. So I think that's almost it. Because I don't think we have any more after these 3, do we? We have those 2 there, but let's see how I'm doing on time. Okay, I've got 15 minutes. Any other questions on this here? This kind of makes sense. Let's look at the next one. So our c is equal to b over 2 squared, yes? And in this case, what's the value of b? Can we divide 9 by 2 nicely? No. If we get a decimal, yes? Okay, I'm not going to divide it then. Because in some cases, having a decimal works out nicely, and others it doesn't. And especially with this here, because with the square root method, we have to square root both sides, and we're adding it to the other side. And if we can avoid having decimals and fractions and intermingling, it's going to be better, especially once we start the square root. We actually start completing the square. It's going to be better to leave these as fractions than to write them as decimals. And squaring negative 9 halves is actually a little bit easier than squaring negative 4.5. Because if we do 4.5, negative 4.5, we'd have to multiply it by itself and then figure out what that is. Here, we know the negative is going to go away. It's going to be positive, yes? What's 9 squared? What's 2 squared? Because we're just squaring the top, we're squaring the bottom, and we're done. 4.5 will still get us to the same answer, which is 20.25. But I feel, at least me, I feel it's a little bit easier to square negative 9/2 than it's going to be to square negative 4.5. So that tells us that we have x squared minus 9x plus 81 over 4. In our set of parentheses squared, well, we'll have x. And what was inside the parentheses before we squared it? Negative 9/2. Because 81 over 4 would be our c. Inside the parentheses, we'll want the negative 9 over 2. Questions on this here? We good with all this here so far? Yeah. And I would look at what they're asking. Find the value. So find the value of c that makes the expression a perfect square. So that's our c. Then write the expression as a square of a binomial. Binomial, so polynomials are what we're looking at. And bicycle, 2. So they're wanting it as a two-termed polynomial that's being squared. Two terms being squared. Because we're talking about perfect square trinomials. Tri is 3. 1, 2, 3. Questions on any of this here? These here, you don't have to write these down at this point because, again, I'm going to have all these listed up tomorrow. I'm going to write them on the whiteboard. These are the steps for completing the square. The first thing is a equal to 1. Is the number in front of x squared 1? If not, make it so. So if it was 2, we'd have to divide everything by 2. We need to make the term in front of x squared be 1. Once we have that, get all the constant terms away from the variables and leave 2 spaces. We want to get the constant terms on one side. So when I said at the beginning, normally we try to get it equal to 0, but there's some cases we don't. That's completing the square. So we want to get x squared and x by itself. Then we want to find the value of c and plug it in. Find the perfect square trinomial and solve, or essentially step 4, write it as a set of parentheses squared, and then use the square root method to finish up. So we're going to run through this here. Now we look at this here, x squared minus 10x plus 7. Is the number in front of x squared 1? Well, yes. So that moves us to step 2. We want to get the constant terms on one side. So we can subtract 7 from both sides. And again, you could follow along with this one here. You don't have to write this down. We'll go through this again tomorrow. And again, I will double check, but there's not going to be a homework assignment where you have to complete the square yet. I just want to show you kind of the walkthrough at this point, okay? Now we leave 2 spaces because that's why we're for the value of c, kind of what we did on these last few. Well, c in our case is b over 2 squared. Well, here the value of b is negative 10. So we have negative 10 divided by 2 squared. Well, negative 10 divided by 2 is negative 5. And negative 5 times negative 5 is 25. So we found the value of c. And like we did on the last few, we plug it in here, which tells us that x squared minus 10x plus 25 is a perfect square trinomial that we can rewrite as a set of parentheses squared, yes? But if I add something to one side, I have to add it to the other. Now x squared minus 10x plus 25, we're going to rewrite as a set of parentheses squared. But we know we'll have x, because that's for our x times x. That gives us x squared. Now the number inside the parentheses before we squared it was -5. So it's going to go into the parentheses here, telling us that we have x minus 5 squared. Now -7 plus 25 is a positive 18. Now we can use the square root method. Square root method is going to tell us that we're going to take the square root of both sides, which over here is going to tell us that we have x minus 5, because these two equals plus or minus. Now the square root of 18 is going to be 3 square root of 2. I got that so quickly because we actually took the square root of 18 earlier today. It was just negative. But last but not least, we do need to get x by itself, so we would add 5 to both sides, telling us x is equal to 5 plus or minus 3 square root of 2, yes? 3 square root of 2 is irrational because of the square root of 2. So there's no nice way for us to add or subtract these. So that there would be the answer. Now again, I'm not expecting y'all to know this now. I was going through this so that y'all have seen it once. We're going to delve into this tomorrow. That's why I split this up across 2 days. But your homework assignment for this year is 3, 5, 11 through 18. So if we looked at that there, so 3 and 5, and 11, 12, 13, 14, 15, 16, 17, and 18. Now 3 and 5 is already a perfect square trinomial. 3 and 5 are already a perfect square trinomial, like the first one we did. So that means we can rewrite those as a set of parentheses squared, okay? So for the first one, the x squared minus 8x plus 16 actually works out to be x minus 4 squared, because you could factor that one side, solve, and do what we did on the first one. Does that make sense? For those first two. But the rest of them, you're finding the value of c and finding it as a set of parentheses squared. And tomorrow we're going to dig into solving perfect square trinomial.